Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're excited to use the Rover in your math and science classroom. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI Technology to make tough to teach, tough to learn concepts accessible to all my students. I'm excited to be joined by our two panelists, Marion Prince and Tammy Jones. Before and after becoming a national T-Cube instructor over 20 years ago, Marion has taught every math and science subject from grades 6 through 12 in a variety of school settings, rural to inner city, urban, and a variety of roles besides classroom teaching, including Title I math, science specialist, to founder and coordinator of a STEM magnet school before the term STEM came into our vocabulary. After completing a doctorate in curriculum and instruction in 2010, she retired from serving public schools to do adjunct teaching for several local universities and coaching for the local middle school FTC robotics team. And I just learned recently this past weekend that Marion also does a lot of work overseas, and I believe Nepal, if I got that right. So
Yep.
Marion, it's great to have you with us.
Nice to be here.
And Tammy is currently a consultant working with districts, schools, teachers, and students from kindergarten through pre-service college. She has 40 years of experience in the classroom, with the last 25 years being in secondary mathematics and science. Tammy has been using Texas Instruments technology since only 1974, so just a couple years ago. So Tammy, it's great to have you with us.
Thanks, Mike. It's good to be here.
Marion, will you do me a favor and discuss our agenda for tonight?
Sure. We're going to focus mainly on an activity that really has two titles. You can find it in two places. The science aspect is called Speed Check, and the math activity is called Rover Rate. Then we will do a quick overview of three additional rover activities: move the cone, Mars challenge, and corralling the sheep, that can be adapted to quite a variety of levels of mathematics. And then we'll have our webinar drawing for a free registration to the T-Cubed International Conference, the virtual, conference, correct?
Yep. Thanks, Marion. That's perfect. And Tammy, we discuss our expected outcomes for tonight.
Yes, we want to make sure that before you leave us tonight that you know where to access the resources that we are going to show you that are specific for the rover and the innovator and the STEM activities. Also, just for the general math and science activities that TI has that are free, that include questioning and extensions for your students and are very engaging and inductive activities. We want you to be able to find those. And then we want to show you just a very brief overview of some of the very basic capabilities of the rover. Not by any means is this exhaustive. It's just to kind of whet your appetite and get you started.
Awesome. Thanks, Tammy. We're expecting a large crowd tonight, so your audio is muted. Feel free to say questions to Tammy or Marion using the Q&A window on the right side of your screen, and we'll also be using the chat window tonight to send general messages. As a reminder, this session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. So I don't want to take up any more of your time. So Marion, feel free to get us started and share your screen.
Okay.
So while Marion is getting set up, let me just save us a little bit of time and hop in. If you will chat and respond either yes or no, if you have ever used or you are currently using Rover or Innovator in your classroom in any way. If this is all brand new, yay, you're going to get to see some cool things tonight. Oh, yay, Marion, we have no's predominantly. We do have a yes. We've got used it once. So we've got very few yeses, but predominantly no's. So we have a good crowd tonight to teach it to and to introduce Rover.
Okay.
Ooh, we got somebody starting this Friday, so this is very timely.
All right.
Oh, and we have one person that tomorrow their students are drawing a poster that they have programmed. That's cool.
Ooh, ooh, all right. Okay, so we have a few experienced people. Are we ready to get started?
Ready.
Okay. Um, the first question is, what is a rover? And if I can show you a picture, this is not as nice as the picture on the TI website, but at least I can move this around and, you know, start by actually showing you where things are. And I'm going to start by showing you the on button. And you'll notice there's 4 LEDs that indicate how well the battery is charged. This is a full charge battery. If there were only 3 lights, that's 3/4. Next to it is a RGB LED, and all that means is it mixes red, green, and blue in whatever combination you want. And next to this is a way to make the rover draw geometric figures, the path, whatever. And this is made for these fine point expo markers that we all love and use. And the on this side of the rover is the power where you can charge up your battery. The Innovator Hub sits right here, and it has outputs on one side, inputs, 3 inputs on the inside. So there's capability of connecting sensors and probes that we won't be able to show you tonight. There's also a capability of decorating or attaching Legos to your rover, and the kids really love that. And underneath there is a color sensor, so you can teach the kids how to program the rover to follow a line. And this is the guts of the rover, and the Innovator has this 10 cable, and it looks horrendous, but it just snaps in and out very easily and snaps back in. And there's great directions on the TI website on how to do this. There is an I2C cable that goes back to where the hub comes in, and the Innovator Hub is connected to the calculator with a regular unit-to-unit cable. And the unit-to-unit cable has an A side and a B side. And the B side is what hooks up to the hub. And the way I remember it, hub ends with the letter B. So the B side of the cable goes into the data port. Whoops, I have this upside down. So maybe this will be easier to read. There is a data port, and the B side goes into the data port. This I2C goes to the circuit board, and there is a brightness sensor, so you can teach kids how to automatically control the rover with a flashlight. So, and to connect up your calculator with the Nspire, it slides right in. I don't move it to all the way so that I can hook up the data port and the hub. And this is a little tight. And now I slide it the rest of the way, and these tabs hold the calculator in. There's a CE side and a CX side, and it only fits one way. And I forgot to mention one of the sensors, which is the most fun. There's a Sonic Ranger sensor on the front that's similar to a CBR.
Exactly.
And, oh yes, there is a ball third wheel to this. And I don't know, do you have any questions? Do you see any questions in the chat?
Not yet.
I
Somebody's writing a grant to get some, hopefully. Good luck to them with that.
Oh, I have one other thing that I forgot to add was that if you're using it with the CE, since the connection is on the side instead of the front of the calculator, you get this effect with the cable it may knock things down if you're driving it and turning it. And so
it does knock things down and get caught.
Yeah. And so what I do, instead of putting it under here, that doesn't help a whole lot, I just twist it around the post and call it good.
And notice Marion has the CE tab on that one because they are made to fit the size of either the 84 or the Inspire, depending on what you use.
Yes. All right, then let me switch to on the website. There are, of course, great directions on how to put this rover together. And you can see here, they tell you what, and these are the great step-by-step instructions. So if you forget what I told you tonight, don't worry. There's plenty on the website for you to use and refer to.
And in the PowerPoint, you're going to get the PowerPoint. So all of this is hyperlinked. So if you click on the pictures, you'll see the hyperlink come up. So don't worry about figuring out, do I remember where it is?
Right, right. Good point. And to get into the activity, I put directions on how to find these because there were a couple of these activities that I had a hard time finding. And so I thought, well, I'll put the directions in here. As I said, Rover Rate is the math activity and Speed Check is the science. And when I compared them side by side, they were exactly the same, except there was one different question in the science version than the math. So I'm going to use Rover Rate and Speed Check interchangeably, and I apologize if I'm referring to the wrong one. I can't remember which one is the math and which one is the science. But I'd like to show you where the Speed Check is, just to show you where it is. The Speed Check is, you have to scroll down a little bit, and it includes all the files. You can download all the 84 CE files and the Inspire files.
Marion, while you're there, will you click just so if anybody is new to the website for TI, if you'll click the 84 plus CE activity files.
Sure.
A couple of things you need to know. It's going to pop up here versus where you can click on the activity window, like individually. And it's going to ask you to like download. If you noticed, it downloaded really quick. Now, right there, if you notice, hang on just a minute. Up at the top, it says extract all. When that downloaded, it was a zipped file. So if you are using your emulators, your Smart View for the 84 or your teacher software for the Inspire, you can't communicate with a zip file. So one thing that I trained myself to do over many times of not having done it and getting caught like, oh darn, I've got to go do that now, is to always, when I download anything that's zipped, just like Marion did, open it and then go to extract all. You just have to know, especially on a school computer, to where it's being downloaded and then to where it is being extracted. So you remember. And see, there it is, Marion. There's your docs if you want to talk about your docs, and or the PDF, either one.
Yeah, and here's all the files that you need. And there are, for the CE, there are 2 programs involved with this activity. And I'll talk a little bit in detail about these 2 activities. Because there is, I had to change things, and so I will tell you that in just a second. Any other things that I need to mention here, Tammy?
I think that's all. We can start
Okay.
and play with the speed check.
Right, the first page of this activity, they go through the overview and the science connections, and this is from the science aspect, but it's exactly the same as the math one. And they tell you exactly what materials you need. It will involve timing, so you'll need a stopwatch. And I focused in on the task. Just briefly, the flow of the lesson is that students use that pre-written program called Speed Check or Rover Rate, whichever one you're doing. And there are 5 speed indexes, and the task for the students are to gather data to answer the question is, how fast is the rover traveling at each index? Now, if you don't have a block schedule, or you can have your students do maybe 1 speed index or 2 or whatever combination. You can have one group do speed index 1 or index 2, 1 and 2, and then another group do 3 and 4, and another group do 5 and 1, whatever combination and time constraints that you have. And they, of course, do 3 trials at each speed index, take an average so that they know that index 1 is so many meters per second, and index 2, the rover is traveling at X meters per second. Then they have a challenge. And this challenge, I ran into a problem because,
Okay.
yes.
Before you go to the next slide, Marion, can I point out just a couple of things here for teachers? Because we've got some people saying that they're new to this. Whenever you use a Texas Instruments activity, notice that there are the questions for students to consider. TI always built in questions. If you are in a district or a state that requires observations of teachers, like we are here in Tennessee, these activities are very rich because the students, as Marion said, they're collecting data. They are investigating, they are interacting and inductively working, they're collaborating. So like every box in your observation is going to wind up being checked when you follow one of these. So that's just a really cool thing. And I want to throw out one question as Marion transitions to the next slide to talk about.
I'm not ready yet. I'm not
Oh,
ready.
okay. Well, as Marion is finishing this up and going, think about, and I don't know, we didn't ask you how many of you were math and how many of you, if any of you, are science. Think about when you see rover rate versus speed check, how this topic maybe is considered in science versus math. And if you can think of any things that might be different or the same.
Okay, the problem that I ran into with this activity is that it said when the data collection, I ran into a problem because the rover was supposed to go 2 meters. And the floor in my classroom was so dusty that it gummed up the pivot ball, that 3rd wheel on the rover. So it interfered with the operation of the rover. And so I went to Home Depot and got 32 by 48 whiteboards. They have them special for teachers, a special size. And and used the whiteboard with painter's tape to have the path on the whiteboard. So I changed the 2 meters to 0.8 meters, and I had to change the dimensions of this challenge because after the students find the time, the speed for an index, the challenge was how much time would the rover go for segment A, how much time for segment B, for segment C and D. And the object was to get as close to the end of that line for D as possible. And so I had to change all those. And if you're curious, I shortened A to 1/2 meter, B was 0.8 of a meter, C was 1/4 of a meter, and D was 3/4 of a meter. And then the students have to run their Navigate program based on the times that they calculated for each segment to see how well their calculations were. Now I'm ready for the next slide.
Okay. And Marion, as you're clicking, we have a question. Joshua asked what the student ratio is to Rover, and I told him, you know, usually I do things 3 to 4 to a Rover, but I would ask you for
Yes.
your input as well.
Yes, 3 or 4. 3 is, 2 is ideal, but you can do about 4. And but I had more calculators than rovers. So what I had to do, if the activity required students to code themselves, each student put their program in the calculator and then slipped their calculator into the rover, like I showed you how to put it in and out, so that each student could try their program. I hope that answers his question.
Well, and Phyllis just had a question that I was going to type. She said she only has one. I only have one personally that I play with my little excursion kids. And I actually let them do, like, I'll have set up like a learning station or centers, which we don't like to use in secondary very much, but same idea. And you can actually just do the one, and the students can do other things. Like you said, they can code on their own TIs and then take turns. That works as well. So there's lots of ways that you have flexibility to do that. So yeah, just takes more planning.
Yep, yep. Are we ready?
We're ready.
Okay. Oh, okay. Sorry, I went too far. I not only changed the distances that I had to do, I also added some things. So I wrote my own worksheet and added some pre-activity questions that involved the students calculating either the distance or the time or the rate before they collected their data. And these questions you can see right here. I have one of the 3 variables missing in number 1 and a different one in number 2 and number 3. Then they
And can I jump in it? Because somebody asked a minute ago about when I said is there science or math would be different, and it said measurement. Jim said measurement is a standard, and yes it is. But I have worked in schools where in science they refer to it as speed. And actually in some science books, teachers have shown me they actually use the S instead of the R. So that's one thing we just need to be cognizant of if we're teaching math and science in the same building. This is a good place to have those conversations to make sure that students understand distance and rate in math to be equivalent to what they're doing with distance and speed. And they're not doing calculus, so they're not taking acceleration and that kind of thing. But that is a distinction just to be aware of if you're math in some of the science books.
And a physics class, they talk about velocity.
Yes.
Distance equals VT, so it's like we have to learn other discipline connections. The reason I put percent error was specifically for the kids that I had. You wouldn't have to include that. But the kids that I had the next year, they were going to be asked to know percent error. So I felt obligated to do that. And here you can see the different measurements that I had up here. Oh dear, I didn't want to do that. Sorry.
That's okay. As she's coming back, Marion, you notice how she's been able to take the Word document and really adapt it for her students specifically. That's the nice thing about TI. You can do that. She actually added a couple of extra questions that she's going to show right now.
Yep, right here.
To describe how the amount of time changes as you increase or decrease the rate setting, and then describe how time of each segment would change if Rover was on a carpet. So think about those and maybe send some thoughts through chat. And I just want to throw out there before Marion gives away what she did. Number 4, how close did your Rover come to the destination? Just, to generate some discussion here, how close do you think close is? What is close enough?
Okay. And I took a little video. The rectangle on the left that you see is to help students have a consistent starting point, so they get the rover in the same place. And this is shows how the data was collected. This would be done 3 times timing each trip of 0.8 meters. It will begin here.
There it goes.
That's Rover rate program, and I'm going to pause it here because I did a sample data. You can see there's 3 trials for each speed setting, and I'll show you, talk about getting the program onto your handheld in just a second. And of course, the student will have the average time and turn that into the speed based on 0.8 of a meter. And then the student has to calculate the times for segment A, segment B, segment C, segment D. And I'll answer that question about putting the program in the calculator in just a second.
I was just answering that. Good catch.
Okay, you have to be careful where you put the lines because you don't want to be too close, otherwise that third ball joint drops off of the whiteboard. How close did I get? I got within about 1 centimeter. And here you can determine what criteria you're going to use for the winner. And these marks that I have on the beginning are to help students. Each group of students will have the same starting point as the group prior and after it. So that's the reason for that. Any questions on that video? Did that bring other questions? I still will answer the question about how to put the programs on the handheld. Do you see any questions on that?
Not yet. So once you have, I think that's good right now.
Okay. All right. This is a look at the program on an Inspire, and there was only 2 places that I had to change. I changed 2 meters to 0.8, and so that was very easy. And the thing about the Inspire, you only have to download 1 Inspire file because each tab is a different program, and at this place, all the student has to do to run speed check is to press enter, and the program will prompt the student after that. And the navigate, instead of being a separate program on the Inspire, is just a different tab. And the on the CE, the program looks a little different. And I did have to play with this program because on the 84 CE, when I go to edit, you can't edit these programs. They are protected programs, so you can't edit them. What I had to do was use TI Connect. This is TI Connect, the programming editor. I opened, I pulled the, when I downloaded the program on my computer, I could open it up. I changed the settings on line 37 and let's see. Yeah, line 5 I changed and line 37. And then what I did, do you see, I can use TI Connect to send that program to my calculator. Do you see the little icon up at the top here? I linked up the calculator to the computer and clicked that icon, and it sent the program to the CE on the Inspire. I used the teacher software to send the program to the calculator. You can use either the transfer tool or you can use the navigator to send the program. There's a lot of different ways to do that. Are there any questions about that?
And we've had a question, is there a Python version? And I'm not sure that these have yet been adapted to Python.
Some of them have, and it will indicate on the website, you know, where I downloaded the where I downloaded the 84 and the Inspire activities. There, I have seen Python versions of these activities, but they're being sent out as they finish them.
Yeah, yeah. And somebody asked if you could edit Python with TI Connect. You edit Python with your SmartView software or the calculator, and you just go in and on your SmartView, you pick whether you're in BASIC or Python, and then you go in and edit it that way. So, and then one other thing that I just wanted to note, some of you that are brand new to this, don't be put off by the programming. See, I'm so old, I remember punching cards and programming. It's the same thing as coding now. Don't worry about this. Marion did it very specifically because she had a piece of whiteboard that was a certain size. This is where you plan early. You don't wait until 7 o'clock in the morning to download this to do it at 8, which you all don't because you're good teachers. You're on here tonight using your time for some free free PD. You know, check in with your coding key teacher, ask for some help, or a student. We so underuse our students as resources to help support us. In your classroom, you probably have a student that codes better than the best coding teacher you have in your district. So, you know, put some things out there and let them, don't be afraid to use something just because Marion modified it. It's not one of those big things, okay?
Okay.
So I asked you to think about these questions a minute ago. So does anybody have any answers they could put into chat here? So what mathematical concepts and skills can you download to handheld in Python? Yeah. Oh, yeah. When you download the program, it will slot it where it goes. It will either slot it as a Python and index it that way, or it will slot it as a basic and index it as a TI basic. So it does that for you automatically. Okay. So what mathematical concepts and skills did you see here? Can you download from to handheld in Python? You can if you have the 84 that has the Python built in, is what I meant to say, Ray. And Michael, thanks for like clearing that up, or were you answering Mark earlier? Okay. But yes, you have to have you have to have the TI-84 Python calculator to be able to download. Marion's holding hers up. It actually says Python. See there? So yeah. And did you see any science concepts? So let's do some math or science. So what math or science did students need? Anybody take a stab? Marion had a, Marion, you want to talk back through what they did with the data to remind them?
Well, I asked them questions like, you know, if they changed the rating setting, what would happen? What would happen if they used a different speed index for every segment of the path? Could they do that? And so if you have some really fast learning students and students that stop, they get everything done, have them try putting a different speed index to every segment and see if they can do that.
So we have measurement and proportions as some of the math. And then here are just, you know, some good questions. Just I used to do what my students, I told my students were math labs, to equate it to a science lab. So whenever you're doing an investigation with a piece of technology like this, and you're a human being anyway, you know, what's going to happen to the time as you increase or decrease the rate setting? And then not just to answer that, but to support and validate your answer and justify. And then what if Rover was on a carpet? What if Rover was on a piece of glass? You know, I mean, you know, if you change the parameters,
Friction is a big science concept.
You know, huge, huge. So think about some of those. Okay, then just to let you know about standards, because everybody lives in the world of standards these days, we are showing Common Core and Next Generation. Here in Tennessee, we say we're not Common Core anymore, but there's not a nickel's worth of difference in our standards. And a lot of people have gone ahead and adopted and kept the process standards, which came from NCTM's process standards back in the day. They used habits of mind. They used tying it all together. So you see that with the math and science, we have some that correlate just perfectly. We have this construct arguments, critique the reasoning. Science talks about engaging an argument. And then we model, and all of the modeling, there's actually 3 science standards that support modeling. They develop and use models, they use and analyze data, and they actually use math and computational thinking. So we are engaging in the how the student learns math and science, not just doing a cool activity, but there really is something behind it. And for those of you that are not familiar with habits of mind or Dr. Cuoco, I went ahead and included this little poster, and I think I sent it to Michael to upload if you all want it. Art Costa and Benna Kalick, way back in the 90s, wrote The Habits of Mind. To me, the more seminal piece was this roles piece that was written by Dr. Al Cuoco et al. And part of it actually got published in the National Council for Teachers of Math journal. And there are roles that we assume. So looking at these, do you think students doing this activity were pattern sniffers? Were they experimenters? Did they have to be describers or inventors? Did they tinker? We don't talk about tinkering with math. Did they have to visualize? Did they have to make conjectures? So, you know, this is a really pretty poster I have now versus the one with magazine pictures cut out that I had in my classroom back in the day. But I wanted my students to know that math was not a passive activity, that when they came in my classroom, we really were going to do things and they were going to really have to engage with it. So did you notice, can you pick out 1 or 2 of those that you think students would be engaged in? Because again, this is a checkbox normally on your lesson plans and such.
I think
Practices.
I would ask my students to identify which role did you play in this activity and have them write about it. Because they need to think about how they were thinking and how they were doing.
Okay. Well, we'll let folks think about that. And Michael said, yes, it's in the document, so everybody will get this poster if they want to use it with their students. Okay.
Are we ready for the next
Ready
one?
to go to the next one. So we'll have
Okay.
enough time. So there's this other activity that is in the Math in Motion that literally you can do at grade 5 to Algebra 1. I have done it with my excursion kids. I do a little supplemental tutorial for a homeschool group that meets, and I did it with them when they were 3rd, 4th, and 5th graders. And I've done it also with my middle school group. The students actually write the program. They're going to do some programming, coding themselves. And this one is just working with coordinates. So it's a very low floor for students to do. Marion's picture has the really cool little plastic cones. I don't. So I used like a couple of Unifix cubes or linking cubes. And that's what they had to ultimately push. So, you know, you can modify that as you want to. And this really was a very non-threatening way to introduce coding to my students. I can tell you that none of the children or the middle schoolers that I worked with were afraid. If they ran the program, and we did it on 84s, I kind of gave them some of the basics that that Marion's going to show you in the next one. The basic commands are very easy. They're just basically saying the rover needs to go forward, left, or right. And they're going to, you know, talk about the axis. If they messed up, they just tried again. And I think sometimes we project our uncomfortableness with not having everything like dictated on our students. And I know we're under time crunches, but they just jumped right in. And, you know, some of them took once or twice and played with it. Some of them took several times, but then they kind of helped each other. Oh, well, what did you do? Well, let me try this then. And then, of course, once the first group gets it, then you start having them like do different things with it. So, you know, this really can be substituted for a typical activity. So if any of you teach coordinate planes right now and plotting, if you're middle school and you just teach plotting on the coordinate axis, we know even in high school students still have trouble sometimes plotting on the coordinate axis. What do you think about doing something like this? Marion, if you want to go back and play the little video, is there a video on that one?
Yes.
Yeah, there is. So as she's playing the video, think about how this might substitute for something you currently do to teach coordinate plane information.
It should be here. I'm not getting my. Okay, I'm clicking. We did have the video.
We did have the video.
Yeah. I think the scroll bar is. There we go.
There it is.
Here's what the typical program would look like.
And it's off.
And if you want to determine a winner, you can grade them on how close they come to the blue dots, whether they hit the blue dots. I nearly hit that one. And here's the cone.
Yeah, here's the ultimate. Can I push the cone?
I got pretty close, you know, it wasn't perfect.
You moved it. You moved it. So, you know, again. So what do you all think? I mean, this one, again, they're having to plot coordinates.
Oops.
So this, I think, is just a cool formative assessment probe or activity to teach plotting coordinates. What do y'all think out there? Yes, no, I'll stick with what I do. Oh, thanks, Belle. Belle says it's nice. We'll take a nice, we'll take a good.
Yeah.
Oh, we got it. It's awesome. Yay. Definitely want to try this one. Definitely. Cool. So we've sold, so this is Move the Cone. Remember, it's math. We have the slide, we have a hyperlink for you. We have an interesting, I like that, Robert, interesting. Okay, so let's see if you want to go to the next.
Okay. All right, the Mars Challenge. I did with a mixed group of 4th and 5th graders. And it's kind of different. Instead of going to the activities tab, I went to the resources tab. Oh, I didn't get the hyperlink. Where did it go? Here we go.
It's the over.
Right. I think it's right here.
Yeah.
It's under the resources tab instead of the activities tab. And you click on the Innovator Rover. And you have to scroll down. Oh, I clicked on the wrong one. Let me go back. Sorry about this.
Oh, it's the getting started. Under resources, go to the getting started with TI technology. Is that what you clicked on?
No, I clicked on this icon because that's what I
Okay,
usually.
TI Rover, and then you go to TI STEM projects. Let's see. Click on that, and then does the STEM projects come up? Okay, scroll on down to the STEM projects. Let's see where it is.
Here we go. Go
Yeah,
to
there
the
it is.
STEM project. This is why we had to do this. I always forget to scroll down to a particular button, and you keep on going, keep on going. I want to mention this one. I would have loved to have done this one tonight. This is a great science math combination activity. And here's the Mars Challenge. There's 2 of them. This one involves a sensor to do, but here's the Mars Rover Challenge. With here's an example of one that has the Python.
Yeah, so there you go.
Zip
There's one of
files.
your Pythons, Mark.
Yeah. And here's the in addition to just the activity, you download, I made my own Mars map, and the students write their own program. So it's not a pre-made. And there is a lot of math that I'll focus on closer in just a second.
But again, notice if they're writing this program, it's not a very high level of rigor
Right.
for this program, so it's still very accessible.
There's just really 3 different, well, 4, turn right, turn left, go forward.
Mm-hmm.
You know, that, and the first one, connect RV. But I like these comments that separate and helps the kids keep track of where they are on the handheld.
And that's that comment vector 1 she's talking about there?
Yes. Right here. This
Yeah.
helps the kids know which side of the volcano. You know, on Mars, there's a huge volcano that's higher than Mount Everest. And the measurements that are required make it really easy to engage the kids. Because I told them, now you're going to be NASA engineers. Your robot is on Mars. You can't go to Mars to measure the distances. All you have is a picture. And so I put the mat way on the other side of the room, and the kids on as far away from the mat. I do have a practice mat that just has a grid, no picture on it. And so they have to measure the angles, and it's a great geometry lesson in what is an exterior angle of anyway, you have to talk in 4th and 5th grade terms, you understand. But I had to teach them how to use a protractor. we had to talk about how do you change the distance on the picture to tell the rover how far to go when it's on Mars. And so there's a lot of math going on, a lot of measuring going on. And, you know, I just love these kids because there was one student who ended up in tears because he didn't come in first. Because of course I had a criterion on who did the course the best. And so without further ado, I'm going to show you, I had two different ways of determining a winner. One for the younger students, when I did it for fourth graders, I gave them points for not hitting cones, you know, but you can, and I had categories, you know, the shortest distance traveled and the closest to the finish. And anyway, you get the idea, I think. So let's see how well I did. Oh no, I hit one.
And as you're watching this, even though Marion's talking about doing this with elementary students, think about how you could adapt it and level it up. Instead of doing points, they could do lines and slopes instead of angles. So there's lots of ways to adapt all of these for whatever math or science you are doing at the moment.
So, you know, I hit two cones and got within 3 centimeters. But you can also use radius. How close did I get? Take the cones away. Just use, because the mat has little crosshairs. You can say within, if you get too close, you get negative points, positive points, and have the kids add their own scores up.
And see how it's drawing? Do you notice that it's drawing as it goes? That's how she's marking where her path is. So you could use different colors. So we love our colored expos. So we could use different colors. You wouldn't have to have a bunch of pictures.
Right.
You could have 5 different colors for 5 groups or something.
Oh, yeah. Or erase it in between. But yeah. I didn't lift it up after this. Okay.
Okay, we are getting close.
Yes.
So the last one that we want to show you and just talk about a little bit, this corralling the sheep. Marion, you want to talk about this? And as we're doing this one, think about extensions. We're going to ask you before, when we're done with this one, for you to give us some extensions before we share our thoughts.
Okay, we have to speed up. So a great place to get the materials for this activity is on the on-demand webinars, the recorded ones. You can search by Innovator Rover and it pops up. You can do other types of searches for other activities, but you can get a treasure trove of ideas. And of course, you could go to the activities, all activities. But the criteria for this is to build a fence that begins at 0, 0, ends at 0, 0, made of 4 lines. You have to restrict domains. If you don't, I prefer to eliminate horizontal functions because the students could use parallelograms and reduce how many slopes that they have to calculate. So I eliminate those horizontal ones. And so the students are picking their vertices and then calculating the slope, calculating the y-intercept, and you enter the calculations that you have. These were the 4 vertices that I picked, and you enter it in, wait a minute. I'm having the same problem as before.
Oh, is it hidden down there? It should be there.
Yeah, it's hidden and I'm not sure. There we go.
Okay.
Okay, and at each vertex, the student has to enter in their information of the slope, the intercept, the minimum and the maximum for the domain. And the calculator shows the student the equation. There's the second equation. There's the third equation. A lot of calculating took me a while to make those calculations. And the last one.
And again, how much richer is this as an activity or an assessment probe than just giving them, 10, here are some ordered pairs, parameters, generate your, do your own. This actually has a purpose and a context.
Right. Here's the student worksheet. And here are the extensions that were provided with the activity.
So before you, those are provided. It's the least amount of fencing, those kinds of things. So what are some other extensions that you might think about doing with this activity that we showed? Marion showed you where they input the order pairs, the slope, it generates the equations, they restrict the domain. And again, you can adapt this. So we're showing you one now that goes all the way into the calculus if you want to. Find the area of the enclosed space. Exactly.
I like that one.
That was an activity Nancy and I set up in our session at T-Cube this last weekend. You could vary the speed. Ooh, who could corral the sheep the quickest? I like that.
Oh, I like that one.
Yeah.
Pythagorean theorem. All right.
There you go. And we even set up a context. We were doing Old MacDonald's Farm with the pigs. But how do you want the fence? Maybe the fence is going to be on the side of the barn. Maybe you want, some water that's at a pond for them to access or something. So again, lots of different ways. It's your imagination. It can be modified. Yes, forcing them to use quadratics or even conics. I love that. Yes, we do not show enough applications of conics. And then yes, I love this. You can allow a certain number of horizontal or vertical. And even where Marianne said she didn't want horizontal, that's a way to level it down to make it more accessible to students that might still be challenged. So as I think Mark as Belle said, that these can be modified. That's the awesomeness of the activities.
And you can include the science, the amount of water that the sheep need. And so there's science that can be brought, even though this really is a math activity.
Yes. Cool. Okay, Mike, I think we're ready.
Yep.
If anybody has any more questions, as Mike is wrapping up, please shoot them through and we'll answer them.
Thanks so much. So one thing I do want to share on our website, again, that's education.ti.com. If you move under the professional development tab in the middle, I know Tammy was just talking about the most recent T-Cube Summit that happened a couple of days ago. But we're also going to be having the T-Cube International Conference virtually this summer. And we've already started scheduling some regional summits as well as some summer workshops. And I believe, Tammy, you're going to be hosting one of those summer workshops?
Yes, if anybody wants to come to Nashville this summer, we're going to be in Murfreesboro at Middle Tennessee State University. And those are the summer workshops. Those are not the summits. The summits are in a different little tab. There's 3 of them. Mike, if you want to go to the summit tab, there are 3. You can even go ahead and see the program. So if you click down to Murfreesboro and click over to details, Mike can scroll down and show you. For the cost of the one-day summit, you get your technology, you get the one-day summit, and there's a lot of program information. You can follow a thread if you want to like follow the thread of coding and STEM, or if you want to just take a bunch of different things. And you also get free registration to the International Summit. And we may even be having a Saturday PD day. Plus, you'll be close to Nashville for the 4th of July if you want to come and hang out with us on the 4th of July. And
Cool.
if you scroll on down, Michael, you can see the program there for them if they want to go back and look at that. The program was there too.
Perfect. And speaking of the T-Cubed International Conference, that again is virtual coming up in July, we are giving away to one lucky winner a free registration, and tonight's lucky winner is Loda Anderson. So
Ooh,
Loda,
congrats.
congratulations. We will be in touch over email soon to give you a little more information about how to register for that, but congratulations on receiving your free registration. And we hope to see everyone else as well at the T-Cubed International Conference. To receive a certificate of attendance, go ahead and click the link in the chat window. Also listed is a link for the documents for tonight. And if you're watching this on demand, go ahead and copy that link into your browser to receive your certificate. Huge thanks to Marion and Tammy for everything they put together tonight. I know specifically, Marion, you had done a lot of work to edit some of these documents, and I really appreciate all your thoughts and time that went into that. Thanks so much, guys.
I was glad to do it.
And thanks, everyone, for joining us tonight. We hope to see you back online next week. Have a great night and stay safe.
Take care.